Welcome to homework.
Okay, so the mass defect equation can be expressed as follows, which is ZmH plus NMN minus AZm. So we know the Z is the atomic number for the nitrogen, which is 7, and MH is the mass for hydrogen atom, which is 1.00782 and when the N is the number of the neutrons in the hydrogen atom, which is equal to 7. And the Mn here is the mass for neutron, which is 1.00866 and the atomic mass for the nitrogen is 14.00307 U. So now we can plug in back to the equation to determine the mass defect, which is equal to 7 multiplied by 1.007825 U plus 7 times 1.00866 U and then minus 14.003074 U and then times C squared. I'm sorry, not C squared. We are looking for mass defect, so we don't need C squared. Okay, and this will give us the mass defects for the nitrogen is equal to 0.112 U. So now let's take a look at the mass defect for the helium. So now we can use these values to determine the mass defects for helium, which is equal to 2 times 1.007825 U plus 2 times 1.00866 U minus 4.002603 U. And this will give us the mass defects for the heliums in this question should be equal to 0.030 U. So now let's take a look at the third case. So for this case, we need to determine the binding energy per nucleon. So the binding energy per nucleon for the nitrogen 14 should be equal to EBN over A. If we expand it, we'll have delta Mn C squared over A. So we know the mass defects for nitrogen is 0.112 U, and C squared is 931.5 mega electron volt per U. And we know the A here is the mass number for nitrogen, which is equal to 14. So now we can plug in back to the equation to determine the binding energy per nucleon, which is equal to 0.112 U multiplied by 931.5 mega electron volts per U over 14. And this will give us the binding energy per nucleon for the nitrogen is equal to 7.45 mega electron volts. So now let's take a look at the binding energy per nucleon for the helium. So now we can plug in back to the equation to determine the binding energy per nucleon for the helium by using such values here. So we have delta EB helium over A is equal to 0.030 U multiplied by 931.5 mega electron volts per U divided by 4. And this will give us the binding energy per nucleon for the helium-4 should be equal to 7.00 mega electron volts. So now let's compare the binding energy per nucleon for the helium and the nitrogen. As you can tell, the binding energy per nucleon for the nitrogen, let me write it down, is greater than the binding energy per nucleon for the helium. And this is in agreement with the figure 43.2 in the textbook. And these are the answers for this question.